Thanks very much for having me here. I'd like to acknowledge and pay respects to the traditional owners of this land and the surrounding region and their elders past, present and emerging who have an ongoing connection to this beautiful country. I'd also like to acknowledge my project team and collaborators named on the slide and the NESP Tropical Water Quality Hub for funding and supporting this research and the RRC. I think my objective here today is to convince you that this project was successful and was a worthwhile investment of hub funds. Well, obviously it was, but I have a greater challenge in that I also need to convince you of the importance of monitoring aesthetic values of the Great Barrier Reef, and that such monitoring will be useful for reef managers' decision making, and that despite what the title says above, we don't actually need to create a whole new monitoring program. We can instead augment existing ones to achieve cost-effective monitoring at scale. So the first half of my talk today will cover the what, the why and the how of aesthetic values and measuring them. The second half will explain what was achieved in the project, and then the third half will reflect on broader learnings, early outcomes and future opportunities. Oh, wrong button. Astute members of the audience will know that as a World Heritage Area, the Great Barrier Reef is listed for having met all 4 of the criteria for natural properties. One of those criteria is to contain superlative natural phenomena or areas of exceptional natural beauty and aesthetic importance. So there's a statement of outstanding universal value that addresses that criterion, and that statement includes a description of some of the features, places and fauna shown in these images. But the reef's aesthetic value extends far beyond that. As a cultural ecosystem service, aesthetic appreciation is one of the fundamental ways people relate to and benefit from the natural environment. The aesthetic attributes of natural places contribute to our well-being. They stimulate positive emotions and they reduce stress. And so going to and experiencing places like these makes us feel better and healthier. And images like these inspire us and they motivate us to travel. So it should be obvious that aesthetic values are a key driver of tourism to the Great Barrier Reef, and they help to motivate people to take action to protect it. However, monitoring and assessment of aesthetic values is problematic, and this problem is not unique to the Great Barrier Reef. There is to date no agreed or consistent framework for assessing and reporting against that criterion. And this has raised concerns about the rigour and consistency of approaches taken by different World Heritage properties to demonstrate that they're meeting it. In the Great Barrier Reef Outlook Report, the assessment of aesthetic heritage values includes an acknowledgement of a lack of evidence, and it notes that the condition is inferred from the state of the reef's natural heritage values. So efforts to address this shortcoming were initiated almost 10 years ago, and a consulting firm developed and applied a comprehensive method to assess the condition and vulnerability of Great Barrier Reef aesthetic values. But that assessment method hasn't been replicated since. It certainly could be in future, but repeating that assessment process would rely on the availability of standardised and representative time series data and evidence. Hence the need for some sort of monitoring program that could provide that information. So that brings me to this project, which sought to develop a monitoring program design that would provide that standard representative time series data to underpin future World Heritage, Reef 2050 and Outlook assessments, and help to inform other management processes, including permit assessments and spatial planning. Because this project is completed, you can read all about the aims and methods in our final report on the Hub website, and I'm going to skip straight to the outcomes. So firstly, by using a collaborative action research process, we engaged with 46 people from a range of end user and stakeholder organisations in co-designing the program objectives and operational requirements to meet the needs of RIMREP. Secondly, based on a review of existing monitoring programs and consultation with some of those program leaders, we identified opportunities for their existing data to contribute to monitoring of aesthetic values and potential opportunities for those programs to collect new data to fill in gaps. Thirdly, based on a literature review and experiment using an online survey, we identified and tested a standard metric for measuring people's aesthetic response to coral reef scenes. Fourthly, we then used that survey data to identify the sampling requirements, and we explored different types of observer bias to develop guidelines on how to treat and interpret those data in a monitoring program. Fifthly, working with project partners Reef Ecologic and with input from our pool of 46 participants, we then designed a set of standard monitoring protocols for data collection involving different types of observers, including experts and non-experts. And then finally, synthesising all of the above, we made recommendations for pilot implementation and scaling up. So I'll briefly elaborate on items 3, 4 and 6, and if you're interested in the rest, you can read all about it in our report or come and chat after the session. Right, so an observer's aesthetic response in the middle there to a natural setting is the thing from which aesthetic value is derived. So this is the basis of our standard metric. And that response is a function of the environmental characteristics on the left, which includes everything they interact with physically in a setting. And the experiential characteristics on the right includes the knowledge and expectations they bring with them, where they're placed in the setting, the activity they're doing, the sensory experience, the information that accompanies that experience, and a range of social, cultural, and emotional factors. So the aesthetic response as an outcome of those characteristics can be quite easily described by the observer and or given a relative score on simple rating scales. Now there are a number of different constructs that we could use to get an observer to rate, but a simple rating of beauty is the most broadly applicable and relevant across different Great Barrier Reef habitats. But considering the variability and subjective nature of those experiential characteristics, it becomes clear that a single observation will not provide a reliable measure. So the purpose of this metric is to find a relative value on a scale that is agreed among a group of observers with enough precision to enable reliable spatial and temporal comparisons. So a key question is then, how many observers are needed? It's also important to account for and control inter-observer variability. And while most of the environmental characteristics in a setting are quite easy to quantify, the experiential ones are much trickier. But not all of them need to be measured, and some of the background information about the observer and their level of experience in the environment will help to explain a lot of that variability, as I'll show soon. So to evaluate that standard metric, and to understand the sampling requirements, we used an online survey of 1,400 Australians, non-experts, representative of the general population, who each rated 40 images of coral reef scenes that were selected at random from a pool of 181 images in total. So each image was therefore rated by a minimum of 380 respondents, allowing us to calculate a mean score and a 95% confidence interval, as shown on the right panel. In the middle of that figure, in the middle panel, you can see the distribution of ratings from 1 to 10 on the scale. And it turned out that at least one person gave the top ranked image a score of 1 out of 10, and vice versa for the lowest ranked image. And on the left are some sample images from the set, one chosen from each quartile. Now, you might recall from the previous slide, I outlined that there are a wide range of experiential characteristics that contribute to the aesthetic response, including the full sensory experience of being physically present in a setting. So that's the sights, the sounds, and the smells. This method does reduce the aesthetic response to visual only, but as a trade-off, it allows scalability for monitoring. In our first paper published from these survey data, we showed that the method and metric work. They're useful and they produce results that are ecologically relevant. So the presence of particular attributes such as clear water, abundant fish, and complex coral structures were significantly correlated with high aesthetic response ratings. We then also found a significant and strong correlation between our non-expert aesthetic rating scores and ratings of the same 181 images by a panel of coral reef scientists for reef health. In a second paper, we looked more closely at the distribution of responses for potential observer biases, and we used a power analysis to determine how many observers are needed to enable robust statistical comparisons. So how many observers do you need? Well, looking at the effect of different sample sizes on the standard error of image ratings, we sought to find a balance between discrimination power and cost effectiveness. So this graph shows the modelled standard error for the set of 181 images, using sample sizes from 3 up to 380 respondents rating each image. And there seems to be a reasonable balance between cost and precision, that is sample size and error, at around 100 ratings per image. We then looked into observer biases and potential predictors of bias. And about 5% of our respondents systematically scored their images at 3 or more points above or below the average. So this is known as extreme response style, where some people tend to give ratings on the extreme ends of the scale, and it's fairly common in social survey data. Using the demographic information they provided, we found that those respondents who did this were more likely to be regular reef visitors. They were self-described as more experienced with coral reefs and had a higher level of interest in coral reefs. And there was also a higher proportion of over 65s in this group. So while these strongly opinionated people inflated our error margin, the positives and the negatives did tend to cancel each other out around the mean. And these tests were really useful in understanding how to treat and interpret results from human ratings of aesthetic beauty and images. And this is an important step in establishing reliable scores that can be used for comparing sites and for monitoring change over time. So establishing those ratings is also a critical step in order to train a machine learning algorithm to perform the same task, because that is the most economical approach to scaling up the evaluation of large image data sets. So over the duration of this project, we collaborated with colleagues from Griffith University, who under a separate NESP project were developing just such a tool. You can read all about their work on the Hub website. I'm not aware that their tool for automated aesthetic analysis of Great Barrier Reef images is quite ready for operational use, and it seems likely that more training will be needed. And I expect this will require a large set of human-rated images, which could potentially be provided by volunteers or citizen scientists involved in existing programs. I am pleased to report, though, that a pilot program of in-situ data collection is underway, led by Reef Ecologic, involving tourists and recreational visitors to the Museum of Underwater Art site at John Brewer Reef, offshore from Townsville. So using some of the protocols developed during this project, their monitoring of aesthetic responses at this site forms part of the wider social and biophysical monitoring requirements to meet their marine parks permit conditions. At this stage, I'm not aware of further uptake of these protocols elsewhere, but I think there's a lot of potential value for other programs to consider adding this small component. So to summarise the broader lessons learned and outcomes from this project, and the co-design process in particular, there was strong interest and engagement from a large group of respondents, including a large group of participants, including folks from Gabrumpa, AIMS, the Queensland Government, JCU, CSIRO, UQ, Griffith University, the Great Barrier Reef Foundation, Tourism Events Queensland, AMPTO, Citizens of the Great Barrier Reef, and several other organisations. Using a structured and iterative process meant that they were engaged at multiple points from beginning to end, and they had a clear line of sight from their first input to the final product. And having more than a dozen participants just within Gabrumpa took quite some internal coordination, and I'd like to give thanks to Michelle Dyer for helping to coordinate that and saving valuable time. So the final program design meets multiple end users' requirements for simplicity, cost-effectiveness and scalability, while showing clear links to management needs and specific end uses. And based on the participants' feedback, it also has clear relevance to reef restoration goals and potential broad appeal for tourism and citizen science adoption and communication. There are, however, going to be some challenges in implementing an ongoing program, including the need for a pilot phase and increasing the uptake by existing programs. There's a need for further AI training, and the data storage and curation requirements need coordination and resourcing. There's a need to benchmark the image ratings from in-situ observations through to post-hoc image assessments by people and then by the AI. And perhaps the first step towards establishing a coordinated and ongoing program is for the management and other lead institutions to come out and say, hey, this is important and we want people to do this. So that brings me to the conclusion. Thank you very much for listening, and thanks to RRC and the Tropical Water Quality Hub for funding and supporting this research.